Hello everybody, welcome to Marketing Analytics course. This is Dr. Shagata Chatterjee from Vijayasoma IIT Kharagpur who is taking this course for you. We are currently in week 11 and this is session 3 and we are discussing about sentiment mining and text analytics, text mining and sentiment analytics. And we are trying to find out, till the last class we have found out that how we can use various kinds of lexicons which are libraries to get sentiment from a data set. So, in this particular class we will actually do that in hand and then we will also try to find out certain other insights from this particular thing. So, the data set that I am going to use is the same old data set which has been used in week 1. So, let me just open the data set. So, this is the data set that we have. If you know the hotel review, the review title at the second column, then the overall rating in the third column and the review content in the fourth column. So, this is the same data set which we will be using and I have senti2.r which is another R file with which we will be doing our work in this particular session. So, first job in any kind of this thing, the first job is to read the data set. So, we first will read the data set. To read the data set, the first thing that I have to do is to set my working directory to source file location. So, this is something that I am doing and then the second step is to read the data set. So, data is equal to, this is equal to signed read.csv. Read.csv is a is a code that reads the CSV file and the hotel data set is hotel review.csv file, which is the same CSV file which is kept in session 3, which we have also used in session 1 also of this week, and then header is equal to true. So, I run it. Once I have run it, I need to check the structure of the data. So, the structure of the data says that you see there is a review title and there is a review hotel name city and there is a review title. Hotel name city is about the name of the hotel and review title is about the title of this particular review and then reviews overall rating and then review content. So, these kind of things are there, some basic things are there. So, then what we will do, the first job is in any data analysis, the first job is that you got the raw data. From there you have to convert it to a corpus. From there you have to clean the corpus. So, after cleaning the corpus you have to let us say do data mining, in this case tokenize, and then for each token, that means each word is a token, find sentiments and emotions and with this we will do some analysis. So, this is our steps that are involved. Now, if I want to know that what I am going to do here is that we remember we will be using lexicons. Lexicons are basically libraries with pre-labeled words. So, pre-labeled words where words are either has been labeled as sentiment or has been labeled as emotions or has been scored as sentiment. So, sentiment scores, these are the three choices that we have and for that we have 3 lexicons. Basically, if you remember in the last class we discussed, there are lexicons, So, 3 lexicons, lexicon number 1 is Bing, lexicon number 2 is NRC, also known as Emolex, and lexicon number 3 is Affine. So, Bing only says whether it is positive or negative, that is all. This guy says positive or negative and then 8 emotions, and this guy says -5 to +5 in this continuum, whatever score that do you have. And then these 8 emotions are, there are 4 negative emotions and 4 positive emotions. The negative emotions are basically sadness, and then disgust, and then anger, and fear. These are the, and in this case there are 8 classic emotions. The basic emotions are like joy, and then probably anticipation, and then here it is surprise, and the last one joy, anticipation, surprise, and the fourth one will be let us say delight. Oh no, trust. The fourth one, if I am not wrong, fourth one is trust. So, these are the 8 basic emotions based on which the scores are given. If my focus is only to find out positive sentiment or negative sentiment, I will use Bing. If my focus is to use the emotion scores also, we will use this NRC library or Emolex library, and that is what we are going to do now. So, I have read the data. So, as I told before, after reading the data, I have to change it to corpus and I have to clean the corpus. So, this is something that I am going to do now. So, the library that will be required is TM. So, I call this TM library, and here I am changing it to my corpus, and data $review content, which is the text of the review, is my data set with which I will play. So, data is equal data underscore corpus is equal to corpus and then vector source data $review content, and I have read that, and this corpus of 942 elements has been created. So, if I want to print the corpus, it will just say that I have 942 documents right now, and if I want to inspect the documents, at least the first 10 is the same old code, and these are my first 10 documents. So, I and my wife had booked tonight, which is the 7th document, and 3 days stay. It was raining all time. The resort is around couple of kilometers to the top of the main road, blah blah blah. So, this kind of thing is there. Fair enough. So, now what the next job is, I have to change it to the lower, means all the text I will change it to the lower case. Why will I change it to the lower case? Yes, so that these two things are understood equally. Let us say somebody says, and somebody says, these 3 things should be same, all will be converted to this will be the case. So, I have to make sure that these 3 guys are considered as the same word. So, that is why I will change it to lower. Then I remove the numbers from the data set, the corpus. From whole corpus, I am removing the numbers. Then I am removing the stop words also. Fair enough. What are the stop words that are currently there? If I just write stop words and like this, so these are the stop words, like I, me, my, myself, we, our, yourself, these, theirs, some of the other things like while, through, of, how. So, there can be some pronouns, some conjunctions, some WH words, all of these things are your stop words, which has been removed from the data set. I removed the punctuation also, and I removed the white space also. So, once I removed all of these things, this data set has become clean data. Now, I have to convert this clean data to understand that this data set ultimately is a corpus, which is a text data, and there are some TM library can work with this kind of a corpus, not other libraries can do that. So, some other libraries require some other kind of data set requirement, and a very basic kind of data set requirement in text data is the character form. So, you change it to basic raw character form. So, I have to do that again, I have to change it to basic raw character form. So, if I see corpus clean dollar and then let us say 1, if I just so wait a minute. So, if I just try to see the how the corpus clean looks like, it is a large simple corpus and the content is, the first content is this, the second content is this, where the content is there and correspondingly the other details are also there. So, if I want to inspect the corpus clean, first element, it will look like this kind of a text. So, what we are trying to do right now is we will be applying an identity on the corpus clean. So, what is the identity function? Identity function will only take the text of it. Identity function will take the text of it and put it in this text column, and then strings as factors. So, change the strings to the factors, this is false. So, do not, when you convert to a data frame, do not consider the strings to be factors, keep it strings, that means keep it characters. So, that is how I am changing the data set. So, now that I have changed it, I got this thing. See, here I got a data frame of 942 observations, where each observation, each cell is a cleaned data file, which is a clean text file, and there is no punctuation there, no capital numbers are there, and anything is there. So, the data frame is data frame, and if I just say that okay, first row, this is looks like this is the first one, second row will look like this. So, each are text which no space, no blank space, more than one space bars are not there, no numbers are there, no punctuation is there, no stop words are there, clean corpus value is what I am getting. Now, what does this NRC and etc. will be doing? NRC to for example, let us say Bing, as I told, Bing is a library which talks about positive and negative. So, if I just call the libraries first. So, these are the libraries that we will need. So, I will call the library one by one. Okay, so, there are some libraries which are not there, like tidy text is not there and tidy text is only not there. So, I will have to install tidy text. So, install packages and then tidy text. So, let it get installed. So, tidy text is in the last class we were discussing in terms of this particular link, we were discussing that. In that link we found that tidy text is the library from where this NRC and etc. things are kept. For example, if I just open the link tidy text sentiment analysis, okay, so let me installed Windows. So, till now we have just converted the corpus file to the character file, and it is a clean version of the character as I just have shown you. So, right now what we will do is we will try to find out what are the sentiment in each of these things. So, the library that we will be required is these 4 libraries. So, I will call them. So, tidy text is the same library, the thing that we are discussing in the last class about the library that has been created, and we were discussing in this website how tidy text can help. So, we have discussed all of this thing in the last class. So, this is something that we are using. Now, in the tidy text will work for our version 3.6.3. So, if you have a earlier version, please download and install a latest version of R, and then you call these libraries. So, next what we will do is, see what is our purpose here, what is the thing that I am going to do here. So, I have a data frame with 942 observations and one column. Each column is one text. From here, I want this particular columns 942 observation again. I want the positive sentiment. How many words are there in positive sentiment? How many words are there in negative sentiment? And if I am using Emolex, then all the 8 emotions, each of these 8 emotions, how many words are there? This is what I want. And then rather I want at the end total sentiment. Total sentiment I can write it as sentiment is equal to probably positive minus negative. So, something like that is what I am trying. So, here how many columns are there? 2 columns here, 8 columns here, and then last one sentiment column. So, total 11 columns are there. So, that is why you are creating right now a blank matrix. A is equal to matrix 0. N row means number of rows, that is dim data frame 1. What is dim data frame 1? So, let us just write down what is dim of data frame. Dim of data frame is the dimension of data frame, which is giving me 942, 1. That means, this data frame has 942 rows and 1 column. Dim data frame 1 is only the first entry of this thing, which is 942. So, basically I am writing that I am creating a matrix which has 942 rows and 11 columns. 11 columns, why? Because one is positive, one is negative, then 8 emotions, and then the total overall sentiment. All of these things are there. So, the values will be the count of words. That means, in document 1, how many words are there in positive sentiment? That will be in the positive one. How many words are there which is associated with negative sentiment? That will go to the negative one. And then how many words are associated with anger, fear, blah blah blah, all of these things will be populated. So, I am creating a matrix like that. Then what I am doing is I am running a for loop. So, this is a for loop which starts from here and ends here. So, let us just assume, to understand what this thing is, let us just assume that I is equal to 1. So, I is equal to varies from 1 to 942, dim data frame 1 means 942. So, I is varying from 1 to 942, but let us assume I is equal to 1, what then is happening? When I is equal to 1, then this is basically the first text, the text of the first entry. So, what I am doing is I am creating tokens for those texts. So, word wise tokens. So, I am just running this. So, if I am running this, what are the tokens? The tokens are basically they are breaking this thing into words. So, place, nice, stay, close, railway, station, owners, base. So, I can create tokens as even sentences also or something like that also. So, here we are creating word wise token, each word is 1 token. So, I have 20 into 1, that means 20 unique words are there in this particular text. Then what I am doing? Just check this part that I am using 1 by 1. So, I will just run this much, okay, copy this much and pasted it here. So, I am picking up tokens and then inner join sentiments from NRC. So, if I run this, it will just say that out of all these words that I have in my tokens, which words are having? These are the words. Out of these 20 words, which words are associated with certain sentiment or emotions from this NRC library. Now, first time you run this NRC, it will ask that why don't you install a library called text data. So, you have to again install a package called text data. Then again you run it, it will say that okay, there is a researcher called Saif Mohammad who has created this library. So, he will say that okay, before you can use this library, why don't you give me the credit for this particular thing. So, you have to write 1 and then press enter. You will face these things I am telling you. So, once you press 1 and enter, then 127 MB file will get downloaded, which is actually the library. So, after that gets downloaded, only you can run this. So, I am not doing that in this particular video because that will take time. In my case it is already downloaded. So, now I am using this NRC library. So, NRC library has 8 emotions and 2 sentiment, positive and negative. So, after that what I am doing is I am joining it, and in this join what I am getting is for every word corresponding sentiment and emotion is getting. So, for example, here there is a word called recommend, which is basically a positive sentiment, and that emotion associated with this word is trust. Similarly, there is a festival, which is a positive sentiment, and the emotion that are associated with this word is anticipation. So, we anticipate what will happen in a festival. We wait for a Diwali or Durga Puja. Then the joy, and then a surprise. So, these are the certain I would say emotions and sentiments that are associated with certain words. So, for first entry only I found basically 2 words, one is 2 positive words and 3 sentiments or 4 sentiments probably, each has a count 1. See, positive has a count 2, this and this, trust has a count 1, anticipation has a count 1, joy has a count 1 and surprise has a count 1. So, other guys are not counted. Then what I am doing? I will be running one step ahead. Now, this guy will give count up to this point. If I just copy and paste and run, this is giving me the count. They are saying that anticipation there is 1 word, joy there is 1 word, positive there is 2 words as I told. Then what I am doing? Then I am spreading it up. Spreading it up means I am making it looking like this: anticipation, joy, positive, surprise, trust and corresponding count. So, whatever was the view previously, I am just converting the view in a row wise. Now comes the next step. Now, remember, we with this thing what we are trying to do, we will be mutating, means changing this particular thing such that I have how many positive? I need all the 11 counts. I need the positive count, I need the positive count, the negative count, the 8 emotions basically, and sentiment. All of these things I need. So, by chance if some sentiments are missing, they should come as 0. By chance some sentiments are there, they should come as corresponding counts. So, this count should be there, this count should be 0 in this particular case. So, how I can ensure that this count will be 0? To ensure that, I am writing this particular function. You see, I am writing POS is equal to if else function. There is a if else function which says by chance positive exists. What does this positive exists mean? For example, let us say in this particular thing, do you think anything called, let us say B or A or B is not here right now, or let us say my name Swagato. There is nothing in my name Swagato. So, if I just say exists Swagato, it will say false. There is nothing called Swagato in my global environment. But if I say exists and then write data, it will write say true. Or if I write exist data frame, it will say true, because there is a data here, there is a data frame here. Similarly, if I say exists here positive is there, which is a value of 2. So, then I am saying that if positive exists, then put positive whatever corresponding value, otherwise 0. For example, negative does not exist. So, in any G this value should be 0. Trust exists. So, trust should be whatever the value of trust has come up, which is 1. but joy does not exist, or joy also exists, but let us say sadness does not exist. So, corresponding value should be 0. So, I am manually populating all the values based on the check that whether that particular sentiment is existing in this particular document or not. And last sentiment is equal to positive minus negative. So, everything I am doing. So, now if I run this much, if I run this much and populate it, I will say that. So, this was the initial anticipation, joy, surprise, up to this point you have got from the previous calculation. Then the rest like positive, negative, anticipation, surprise, sadness, anger, and there were 3 more variables which has not been printed here. These are the calculated one. So, because there is nothing negative, NEG has come 0. Because there is nothing sadness initially, SAD has come 0, and so on. Now, I change this thing to a numeric variable and save it at B. So, what is B then? B looks like this 1 1 2 1 1. Now, remember the last 11 values, which is 1 2 3 4 5 6 7 8 9 10 11 up to this. These values are something that is meaningful to me. Last 11 values are meaningful to me, the rest of the values are not so meaningful to me. So, this is something that I will be picking up, the last 11 values. Why 11? Because there are positive, negative, then trust, joy, anticipation, surprise, sad, anger, fear, and this and let us say disgust. There are 8 emotions and then 1 sentiment. So, 5, another 4, 9 and 2, 11. So, these are my basic values based on which I will be trying to calculate everything. So, that is what I am taking up till 11. B is equal to B till 11 means take last 11 values and populate it in AI. That means, in the first row of A, okay, so A I have not created. So, in the first row of A, because I is equal to 1, populate it. That means, right now the A has become like this. Everything is 0. In the first row it got populated, the values are coming up. Now, I will run this for the whole loop. So, if I run this for the whole loop, I will select from here, I will select the whole loop and run it. So, you can check what is the count here. Right now, if I just refresh, I is equal to 82, I will run from 1 to 942. So, just keep on checking this number. So, it will run from 1 to 942, each one of them it will pick up, calculate based on NRC library what is coming up as your various kinds of emotions and sentiments, and then it will populate it in A. Now, the next job is to join this A with the original data set to see that how emotions and sentiments is driving your rating behavior. So, how the emotions and sentiments expressed in the text will impact your overall rating is something that we are trying to do. So, let us see. Now, I will bind this A, which is these values where there are sentiments and emotions all are populated here. I will bind this one, just 1 minute. Yeah, I will bind this one with the data set. So, I have bounded it, fair enough, and then the data set has become like this. The review title, overall rating, content, and then positive, negative, etc., and sentiment, those values are here. So, those values are given. So, next what will I do? If I got these values, next what will I do? I will just go and find out how this thing is impacted by, let us say, positive plus negative, how negative and positive sentiment is impacting me, and how the various emotions are impacting my overall rating. So, first thing is positive and negative, and then the emotions. So, let us see first positive and negative. So, if I run this and then if I try to see summary of fit, it is giving me that positive ratings are highly associated with my codes, but negative are not so much. So, my overall rating is highly I can say being explained by my positive ratings, but this is coming negative, which is something we have to check first. This should not come negative, you have to check this code once again. Now, next thing is I am trying to check the emotions, let us say along with that. So, I have come up with emotions and summary of it. If I see, then certain emotions, summary of fit 1, summary of fit 1, then certain emotions are also associated with, for example, disgust and fear. As you feel disgust or fear, your rating goes down. Even sometimes as you feel trust, your rating goes up, something like that. But I can believe on this only if that the particular this particular x variables are not correlated with each other. So, to check that, I will call for a library called car. So, car library is not there, we will quickly install this car library. It is a small library, it will not take much time. So, car library helps you to check all this multicollinearity and etc. So, that will get downloaded. Okay, it has been downloaded, and if I now call the car library and want to check the multicollinearity, it will give me the variance inflation factors. And you can see that anticipation has very high variance inflation factor 7.10, and sadness is also high. So, our cutoff is generally 4. So, I will first drop anticipation. So, here I dropped anticipation and run this thing once more, and if I now check it, with the rest the VIF is more or less okay. Still sadness is high probably. So, I will also remove sadness from my model, and then I will run the fit 2. So, if that is the case, then now after removing sadness and etc., everybody's VIF is smaller than 4. So, no multicollinearity anymore, and this is my observation. See, now I can tell that positive is properly contributing towards my overall rating. Now, it makes sense. Then trust is also significantly contributing towards my overall rating. Surprise has a negative. So, not everybody likes surprise elements. Do not keep, even if it is pleasant surprise, preferably do not keep surprise elements. Fear and disgust, probably disgust is the most contributing emotion towards the negative rating. So, these are some of the insights that you can generate from the text data, which can be used to ultimately predict the quantitative data that are available. So, basic job is to find out from the text the emotions, the sentiments, populate it in a tabular form, and then use that table for any prediction purpose. So, that is where we will stop today. In the next video, we will discuss a little bit about topic modeling. Thank you.